Yes, hello everyone. My name is Rees, and I'm very excited to be here. As said, I'm a technical specialist for Unity's technical marketing team, which was formerly known as evangelism. Today, I hope to answer the question of how is VR changing training? I'll begin by sharing some statistics on the impact of VR in training scenarios. Then I'll dive into some use cases of different companies and applications on how to train using virtual reality. From there, I'll share some insights on current trends that I've seen in the virtual reality space, followed by some future trends that I think are important to keep in mind when building these types of applications. So last year, we worked with the research firm Forrester and found that staff training is one of the most challenging areas because most companies rely heavily on traditional forms of visualization, like in-person interaction, physical models, and 2D visuals. As a result, we're seeing a shift in how companies are empowering workers with knowledge and skills, going from binders and instructor-led sessions that still rely on 2D presentations and videos to interactive, immersive training and guidance on platforms like augmented, mixed, and virtual reality. Many companies are finding a solution to these problems in real-time 3D. The same study we did with Forrester found that nearly every company using this technology finds it valuable for staff training. As this presentation continues, you'll see common themes like higher retention value, more immersive training scenarios, and the ability for more varied scenarios as well when using real-time 3D and specifically VR. So I'm going to go over a brief intro of real-time 3D since we're going to be using this a lot. The world is changing. We used to build content for a 2D world where it was very static and stale, and your users are demanding rich, interactive, real-time 3D content, which traditional tools just can't adapt to. So what do you need? What was static will now be interactive. What was asynchronous has to be real-time. And what was 2D is now 3D. So let me bring this to life with some examples. Unity is well known in the forefront of the entertainment space for powering 50% of the top 1,000 mobile games. And in the film space, Unity enabled shooting The Lion King in VR as if they were on set, which empowered them to be able to experiment and ensure that they achieved their vision. But less people know that Unity is already a partner to enable leading AEC, automotive, and industrial companies like Shop Architects, who are using Unity Reflect to design a residential tower in Brooklyn. Unity helped the stakeholders to accelerate communication and construction planning on this landmark project. Or Tactile, who enable companies to use AR and VR to visualize processes on top of real-world equipment, enabling greater flexibility and speed in training and maintenance. Vario is partnering with Volvo to enable safe driving with an augmented reality headset. It can give drivers visual alerts to highlight hazards on the road. And Unity and NVIDIA collaborated with the BMW Group to showcase the 2019 BMW 8 Series Coupe through real-time ray tracing. So the image is not a real photo, it's completely digital. But let's dive into some real-world training examples specifically. The first is an example from Virtual Marine, which uses virtual reality to help offshore oil and gas companies, shipping companies, the Coast Guard, and more to help with training and rescue operations. Most of the accidents that occur during lifeboat drills are due to defective equipment, lack of maintenance, improper training, and poor communication. And we also know training in the real world is very expensive and dangerous, especially with watercraft. So Virtual Marine introduced a better way. Here's an example that Virtual Marine created for Canada's Coast Guard, so they can actually drive specific vehicles. In this case, it's a fast rescue craft. and you can see the operator is using the actual controls for the craft. One thing that's exciting for these virtual reality applications is that you can run through a variety of scenarios and situations. In this video, you can see the weather changing, which can offer a vastly different experience for the operator. The highly realistic experience is built entirely in Unity, and the simulation scenarios can adjust time of day, weather, and sea conditions in order to test operator navigation and proficiency skills. Triggering these changes can be trivial in real-time 3D, but can offer endless possibilities for how to train and prepare for unexpected situations. Here's an example of VR training from the US home improvement retailer Lowe's. Lowe's wanted to dramatically improve its do-it-yourself skills training clinic to help customers visualize their home improvement projects by providing an immersive, intuitive experience. This application allows customers to go through every step of scenarios like tiling your bathroom before trying it in your own home. In the video, you can see the area that they call the hollow room, which will take them through every step of tiling a bathroom. To create a realistic experience, they used Unity to create rendered textures and a masking auto leveling plane to provide the user with visual feedback and dynamic layers when they were completing tasks such as mixing or applying the grout. Lowe's found that customers who did the VR experiences instead of watching a YouTube tutorial had 36% better memory recall. They also found unskilled DIYers to achieve a memory performance level comparable to that of experienced DIYers. Lowe's found that they were able to increase customer confidence by providing this immersive training experience, since the customers got to actually experience every step physically. Now let's look at an example from the Justice Institute of British Columbia, JIBC, which runs correction centers across British Columbia in Canada. The JIBC wanted to better train its guards to handle a range of situations that may arise in the prison system, so it built a highly realistic VR project, which you can see here. They created a Unity-based VR environment with 10 different branching scenarios for staff to enter. They deployed the application to the Oculus Quest so that they can set up training almost anywhere with just the headset and the controllers. The Quest offers insight tracking that translates the user's movements into the VR environment, no matter which way they are facing, and it provides room scale tracking without external sensors. Hundreds of officers have passed through the training to help enforce proper policy and procedure adherence, keeping officers safe and reducing litigation. As well as maximizing safety, the initiative helps increase retention and decrease the gap between the classroom and the real-world environment. Now I'd like to shift a little bit and talk about some current trends in the virtual reality space. One of the big ones is standalone, which is the ability to have an all-in-one device or an untethered or unwired device. On the mobile side, you're seeing the Oculus Quest, which continues to outsell and outperform a lot of the other headsets, with its second version having been announced. It offers this all-in-one experience so that you're not limited by a high-end PC or a specific location in order to try out or deploy your experiences. The Oculus for Business platform also offers additional utilities to streamline your development and distribution. On the high-end side, we're seeing companies like HTC, which continues to adapt and offer things like a wireless kit that works with their latest headsets. This gives you the ability to have the high-end tracked experiences, but not be directly tethered to the PC. Next, we are seeing a lot of hand tracking. Hands are really becoming a more important factor in the virtual reality space. You're seeing controllers like the Valve Index controller, which does individual digit tracking. This allows for you to have a much more embodied hand presence in the experience. As you move your hands around, you'll see your individual fingers, and that's completely reflected digitally inside the experience. On the standalone side, Oculus has added full hand tracking to the Oculus Quest. It's able to utilize the built-in cameras to track and show the hands. The big win here is that you don't have to teach users about your controllers, like how to hold them or what buttons to use. They just see their hands working as is in front of them, which is much more user-friendly to pick up. We're also continuing to see computer vision and machine learning play an important part in the virtual reality space. We've talked about companies like Oculus, as well as others, who are starting to use things like computer vision for tracking both controllers as well as hands and more. On the high-end side, we're seeing companies like Vario, which continues to iterate and add new functionality to its XR1 mixed reality headset. On the right-hand side of the slide, there's a GIF highlighting the ability to recognize and track a virtual marker, and pull that tracked content into your virtual experience. This provides much more unique opportunities to what's possible. Now we'll look at a couple of future trends. These are some interesting topics that we'll continue to see improved technology and development in, and offer a lot of exciting potential opportunities in the future. The first is multi-user. Where there are a lot of multi-user experiences today, they continue to be more and more advanced and wide-reaching, which with larger groups and more people accessing shared content at scale. Companies like Audi enables people locally as well as all around the world remotely to collaborate digitally for cases such as design reviews or training. In general, these co-training opportunities ensure the collaborative and personal feel is maintained, keeping the social element to training on the job. Next is mixed reality, with the idea of having virtual content that can interact with and understand the physical world that you are in. One of the biggest leaders in this space is Vario, which I mentioned earlier, with its XR1 mixed reality headset. It gives you the ability to pull in the camera feed from the device and allows you to see into the real world. Since it's rendered on the headset, you're able to add in digital content on top of the real world. The example shown is a moose, showing you how to react when driving on a closed course environment. On the standalone side, we've got the Oculus Quest, which allows what they call pass-through video functionality, which enables users to set up their boundary system as well as get spatial understanding inside of your home menu. Next, we have haptics, which are continuing to evolve and play a more important role in virtual reality. If you aren't familiar, haptics are really to enhance the feeling and touch of a virtual reality experience and to improve its immersion. There's companies like HaptX, which uses advanced haptic technology with their own custom controller or glove technology. This technology allows you to feel different sensations like raindrops or liquid on your hand, as well as restricting your hand movement to simulate what you are digitally interacting with in the experience. There's also companies like Subpack, which is a tactile audio system that you actually wear on your body. It's directly linked to the audio of the experience. So as an exciting moment or loud noise happens in the experience, you can actually feel that on your body, which adds to that layer of immersion. And last but not least, we are seeing some exciting advancements in neural interfaces. The idea of having your mind to interact more intuitively and understand what people are thinking as they go through these training and virtual reality experiences. Companies like Control Labs, which is a startup pioneer for non-invasive neural interfaces that was recently acquired by Facebook, and Neurable, which makes neurotechnology tools that interpret human intent, measures emotions, and really provides this telekinetic control of digital experiences. These are both exciting technologies that offer a little glimpse into what the future might hold for neural interfaces as we continue to learn about the brain and how it may interact more closely with computers. Thank you very much for having me here today. I hope this presentation has given you a little bit of insight into what's coming in the future and the types of technology that has been and will soon be leveraged to allow for more immersive, interactive, and effective visual training experiences.